Okay, number 4 from test 2 is essentially an equilibrium problem. We have two identical springs, both having the same spring constant, 50 newtons per meter, and they're supporting a 5 Newton weight, as shown in the picture. What is the change in each length of each spring when the weight is hung on the springs? And what we show here is a picture of the springs after the weight has been hung. So the final resting position is 30 degrees between the vertical to the spring. So let's begin by asking the question, what are the equilibrium conditions? Well, we can go to Newton's second law, and we know that for equilibrium, the sum of the forces in the x direction must be 0, and the sum of the forces in the y direction have to be 0. And I show the tension forces from each spring supporting the mass. The tension for the A spring is denoted F sub A, and for B, F sub B. Now let's write the equilibrium condition in terms of F sub A and F sub B, the force of tension in A and the force of tension in B. And we have that the force of tension in the y direction for A and the force of tension in the y direction for B minus the force of gravity on the mass must be 0. And we write that in terms of the force of tension and the cosine of the angle. Now a quick question here is, why am I using cosine? Shouldn't I be using sine? Well, no. The fact is that in this case I'm measuring from the vertical axis rather than the horizontal. So now what is the force of the spring in terms of the length change and the spring constant? Well, we know that the force of tension in A and force of tension in B will be equal to the spring constant times the change in length that we will denote as L. And since we have both of them the same acting together, it's going to add. Now the equilibrium condition becomes what? Go ahead and write it down. And that's going to be 2 times KL cosine theta minus mg equals 0. Now, you should be able to understand where the 2KL came from. Simply that I had FA cosine theta plus FB cosine theta, and FA is equal to KL and FB is equal to KL. Now let's solve for L. Solving for L, we have that L is mg over 2k cosine theta, which is 5 newtons over 2 times 50 cosine 30, and a change in length of 0.058 meters. End of problem.